Okay, take two. Hopefully this time we can actually see the notes. I got some feedback about the written one homework, and it sounds like it would be useful to talk about domain and range, and specifically writing domain and range with interval notation. Now the directions didn't say to use interval notation, so don't panic if you didn't, but know that moving forward, we are going to specify that we use interval notation, so it's going to be helpful to get comfortable with it now. And before we actually go into doing number two, I thought it would be helpful to just kind of use two of our parent functions to review interval notation. So if we look at the exponential family, we could use Desmos to get an idea of what it looks like. We have a horizontal asymptote at y equals 0, and then the graph looks something like that. Notice I'm doing y equals 2 to the x as the example. And that's not perfect, but it's good enough. It'll do what we need it to do to find the domain and range. So remember, our domain is going to be our x values, the inputs, which is the horizontal axis. So here's the x-axis. And with interval notation, you're always going to write it from smallest to biggest. So if we look at the smallest number that we can plug in, right, we can notice that this graph goes forever in that direction. And the reason that that's important to the domain is because, right, imagine if you had like negative 100 million, right? Let's say that's all the way out here. Well, we have an output, so we know we can plug that in. If we had negative 500 million, right, we're out here somewhere. Since the graph goes on forever, we know that we have an output, so that can also be one of our inputs. And so since it goes on forever, we start our interval, that smallest number, as negative infinity. And with plus or minus infinity, we'll always use a parenthesis. So from negative infinity, and then as we let x get bigger, right, so we're traveling to the right, again, we can see that the graph goes on forever, so we're going to be able to plug in any number we want after that. Pick 100, right? You'll have an output way the heck up here, but what's important is that 100 is defined. And so since the graph goes on forever, we say that the domain is from negative infinity to positive infinity. Now, I think it gets a little bit more interesting with the range because we start talking about whether or not we need to include values. And what I mean by that is if we look at our range, in other words, if we look at our y values or our outputs, right, we only have graph above the x-axis. We only have outputs that are above the x-axis. We never cross the x-axis. In fact, we never even touch the x-axis. We get super duper close. Like we'll have outputs of like 0.01, 0.001, 0.000001, but we'll never actually hit 0. We'll never have an output of 0. So we cannot include that in our range. And to indicate that we're not including 0, we use a parenthesis. And so that says that we can get super duper close to 0, but 0 is not actually one of our outputs. And again, we go from smallest to biggest. So our smallest, right, we're starting at super duper close to 0, but not 0. And then as we move to the right, we're going to output every number after that because it goes up to infinity. It goes up forever. So we say our range is from 0 to infinity. And again, you always use a parenthesis with infinity. So the takeaway, or the lesson to kind of take from that, is that we use parentheses to indicate that we don't want to include the value in the set. And we always use parentheses for positive or negative infinity. Now that we've looked at a case where we're not including 0, I think it's useful to look at a case where we do include 0, which is why I want us to look at the absolute value together. So again, if we use Desmos, we can graph this. Good enough graph, doesn't have to be exact. If we want to find our domain, that's our x values, our inputs, it's that horizontal axis, right, x. And again, the graph goes on forever, right? So we can plug in negative 100, negative 1,000,000, negative 3 trillion. Our smallest value, so to speak, we say is negative infinity. And then since it goes on forever, again, right, we can go up to positive infinity. We could plug in 100, if we say that 100 is right there, right, we could plug in 5 million. The graph is gonna go on forever. So we can plug in anything we want, and we're not gonna run into problems. Our range, though, is pretty similar to the exponential, except for this time, right, we do output 0. In fact, we have the point 0, 0 on the graph. So the lowest value that we output, and we actually do output it, is 0. So I'm going to use a bracket. And then the graph goes up forever. So the biggest number, right, we approach infinity. So the takeaway here, we use brackets to indicate that we do want to include the value. With that in mind, we're going to look at number 2, parts A, B, and C from the written homework. So starting with part A, and I actually really like this problem because I saw a lot of people reflecting on it in the part B part of the assignment, and I thought it was just, I'm a huge fan of learning from mistakes, so I thought it was really, really cool to be able to see y'all looking at your own work and learning from it. So it seemed like a lot of people looked at this and they were like, yeah, okay, I can get behind the fact that this is a function, because each input has exactly one output, right? That's what it means for a relation to be a function, is that each input has exactly one output. So a lot of us were comfortable with this being a function. And then here's kind of what I saw through the reflection process. And again, I think this is really, really cool. So this isn't meant to like shame anyone. This is actually, it's a positive thing. So if you're in this boat, don't feel bad. Feel proud of yourself for learning from that mistake. But I saw a lot of people said, you know, I made this mistake that I thought, looking at this graph, that it was okay to connect the dots. Right? And by connecting the dots, I said, okay, So the smallest number that I plug in is -1. And then the biggest number that I plug in is 3. So this is what a lot of people started with, right? But then if we look at the key, that's not what's there, right? In fact, just by altering the relation, we've made a mistake. So we're actually not allowed to play connect the dots. Our childhood is betraying us there for those of us who played connect the dots. We cannot connect the dots. And the reason then, if we're looking at the relation as it was actually given, right, we can tell that this interval is incorrect because if we picked a number, right, this interval says, hey, you can plug in anything you want between -1 and 3, including -1 and 3, since we use brackets. So pick any number you want in there. You can plug that in. So if I picked 1.5, which is in that interval, and right here on our graph, right, we don't have an output. There's nothing there. So that's kind of like a red flag that's going off in our heads to indicate that something's funky with this interval. So from there, a lot of you said, oh, okay, I get it, right? If we want to just list these specific values, right, I can only plug in -1, 0, 1, 2, or 3. Those are the only values I'm allowed to plug in. And to indicate that these are the only values that we're allowed to plug in, we're going to use what's called set notation. And set notation is indicated by the curly brackets. So, again, the takeaway: we use set notation which is usually indicated by curly brackets, to list distinct values in a set. Right? You could have 5 values like we do here. You could have 1 value. You might have 20, right? But it's the fact that there are individual distinct values that you need to list out. That's what tells us that we need to use set notation. So, along the same lines then, looking at our range, right, we have an output at -2. We have an output at 0. We have an output at 2, an output at 4, and at 6. And again, it's just these values, so I'm going to use curly brackets. Part B, I think for the most part this one went okay. It was just a matter of knowing how to correctly use interval notation. So starting with whether or not it's a function, if we look at that graph, we can see that every single input, no matter which input you pick where it's defined, it'll only have one output. So yes, it's a function. The domain, right, our graph goes on forever. So we could plug in -100, right? We could plug in -200. Doesn't matter, it's going to go on. So we're going to start at -infinity. And then we can see that we don't really have issues until we get to -1. Right? It's at -1 that we have this vertical asymptote. And so we don't have an output for -1. We can't plug in -1. So if we can't plug in -1, we don't want to include it in our set. So we're going to use a parenthesis. 'Cause. 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 'C But after -1, right, we have graph again. So we could plug in -1/2, we could plug in 1, we could plug in 3, we could plug in 100, right, all the way out to infinity. But again, we can't plug in -1, so I'm going to use this parenthesis right here to say that I'm not including that value. This symbol between these two intervals is called a union. It's just basically it's fancy math talk for and. So in other words, this is saying I can plug in any value from -infinity to -1 and from -1 to infinity. Similarly, for our range, right, the smallest number that we output, so to speak, since our graph goes down forever, is -infinity. And we output all of the y values until we get to 1. Right, when we get to 1, we see that we have that horizontal asymptote. We can see that it's not crossing it, so we don't output 1. So we want to make sure that we don't include 1. So I'm going to use that parenthesis, union, and then again, we output all the numbers after that. So from 1 to infinity. Okay, last problem we'll talk about is part C. And again, this was another one of the problems where I saw a lot of people reflecting on it, and I thought it was really, really awesome. A lot of folks said, hey, initially I argued that this wasn't a function. It bothered me that when I looked at x equals 2, I saw this dot and what I thought was another dot at 3. Right? But then they said, hey, but then I noticed I have one dot that's actually filled in at 1, and this other dot is open. So since that other dot is open, it's not actually defined at 3. It's only defined at 1. So the output for x equals 2 would be 1, because that's the dot that's filled in. And all of our other inputs, right, they all only have one output. So we can say that, yeah, this is a function. From here, talking about the domain and range, we'll just kind of start with the takeaway. It's useful to remember that if you have an open dot, like we just talked about, right? We have an open dot here, and right there. This corresponds to using a parenthesis. But if we have a filled in dot, this corresponds to using a bracket. And again, the reason that is because if we have that open dot, we're saying it's not actually defined there. So we're not actually including that value there. But if our dot is filled in, we are including it there. It is defined there. So that's why we would use a bracket. So for our domain, for the x values, the inputs that we're allowed to plug in, we can't plug in 0 because we have that open dot there. But we can plug in any number after that because we have outputs, right? I could plug in 1/2 and I have an output. I could plug in 1.5 and I have an output. So I can plug in from 0 but not including 0. And then we think, oh no, it stops here, so I have to stop it. But we actually don't. right? Because then we pick up right here again. So we can actually go straight to 4. And we can plug in 4 because we have that closed circle. So I'm going to use a bracket to say that, hey, we can include 4 in our domain. We're allowed to plug it in. There's a closed dot. And then we have a gap, right? We can't plug in anything between 4 and 5 because there's no graph there. But I can plug in numbers between 5 and 7. Our range, it's going to be a similar process, except for now we're looking at our output values, our y values. The smallest number that we output is 0. And we actually do output it because this dot was filled in, right? It started out filled in. So we output 0, we output everything from 0 to 2. And again, the dot is filled in at 2. And we have a gap between 2 and 3. But we do output the number 3. So we're going to make a union, fancy talk for and. And since it's one distinct value, I'm going to use set notation. So this says that we output all numbers, any real number between 0 and 2, and the number 3. Hopefully that helped. But if you still have questions, feel free to ask them in the Q&A board, and then one of us will answer them there. Otherwise, I hope y'all have a great weekend and are taking care of yourselves. And I will talk to you again soon.